understand the relationship between the data and the model, how we get the predictions as well too, so that when you leave this lecture, you're able to take the data set yourself and then go through it. Or when you use a statistical package, you're not like, oh, what is this doing? And it's just a black box. It's like you actually can do this yourself. Okay, so we want to choose gamma and alpha to minimize the sum of the square residuals, right? The negative sum of the square residuals. What we've done is we've come up with what these epsilons are. It's just the difference between the actual data and the prediction, right? And so let's write this out. So minus SSR is going to be minus 1 over n. The sum of I equals 1 to n. And then this epsilon here is just going to be yi. Well, remember yi is just log wages. Minus alpha hat minus gamma hat si, all squared. Right? All we've done is just taken this and plug this into our formulation here. And what we're going to do is we're going to take so what we're going to do now is to find the gamma hat and the alpha hat. We'll take derivatives of equation 1, where this is equation 1, with respect to gamma hat and alpha hat, and set them to 0. And solve for gamma hat and alpha hat, which is exactly what we did with utility maximization, right? Okay. Everyone with me so far? And let me know if I'm writing too quickly. So let's take the derivative of minus SSR with respect to alpha hat. Let's do that first, right? So we get a minus 1 over n. This is just a constant. We still have our sum from I equals 1 to n. And now we're going to be taking the derivative of this quantity here. What's the derivative of this quantity here with respect to alpha hat? So we have this quantity here squared, so we need to take this 2 and do what? To bring it down. So we get 2 times yi minus alpha hat minus gamma hat si raised to the power of what? Raised to the power of 1. And then we have to multiply by what? Then we have to take the derivative of the inside, right? Because the chain rule says we have to multiply through, we have to take down the exponent and then reduce this exponent by 1, and then multiply by the derivative of what's on the inside. And what's on the inside, the only term that depends on alpha hat is this minus alpha hat here. So what's the derivative of minus alpha hat with respect to alpha hat?
It's minus 1.
It's minus 1. So we multiply this by minus 1. And we set this equal to what? 0, right? Okay, good. And so this is the same thing as 2 over n, the sum on I equals 1 to n, yi minus alpha hat si is equal to 0. I just took this 2 out. Now, we can multiply both sides of this equation by a half to cancel out this 2, right? So we can multiply this by a half, and we can multiply this side by a half too. What's a half times 0? 0. Okay. Now when we multiply this by a half, this 2 becomes just 1, and so we end up with 1 over n. And I'm going to break this out into the component terms. The sum from I equals 1 to n, I equals 1 to n of yi minus 1 over n. The sum from I equals 1 to n of alpha hat minus 1 over n. The sum from I equals 1 to n of gamma hat si is equal to 0. Everyone sees that so far?
Okay, you just multiplied each side by 1/2.
You just multiply each side by 1/2. Everyone sees that so far? If I take, so this y is the log wages for everybody. If I take this, right, and I add up all of the wages for everybody and I divide it by 1 over n, what is that going to give me? If I take the wages of everybody in this class, like there are 30 people in this class, and I sum it up, and I divide that by 30, what does that give me? The average wage, right? Everyone sees that? And I'm going to represent that by the expected value of the wage. So this term here is just, and you guys in the back, can you see down here? And you can see down here as well too? You can't see down there. Okay. What I'm going to do is I'm going to continue this up here. Okay. So what we're going to get from here is this first term you guys said is the average wage, right? The average log wage. And so that's the expected value of yi. That's this term here. Now, this alpha hat is just a constant. This is a number like 3 or 5 or 0.2. And if we sum this 5 times, if you sum $5 5 times, you get 25. If you sum alpha n times, what do you get? You get n alpha, right? And so the sum from I equals 1 to n of alpha is just going to be n alpha. So we get n alpha divided by 1 over n, which is what? Alpha. Yeah. Does that make sense? Does everybody see that? Okay. This is basically saying what's the average value of alpha? It's just alpha. So then we get minus alpha. And over here, we have gamma times si. We can take out a factor of gamma, right? We can take out a factor of gamma, and so we just get minus gamma times 1 over n, the sum over si. What's the sum of si divided by n? The average school length. Does everybody see that? And so what we're going to get is minus gamma times the expected value of schooling is equal to 0, right? Are there any questions about this here? Okay.
Why do you do expected value of schooling? Like, why is that 180?
It's times gamma. Does that make sense? So let me write that.
Yes, yes.
Does that make sense? Does everybody see that? Who understands that? Raise your hand. Who does not get that? Okay. Okay. Thank you for asking. Like always ask if there's a question. So we want to solve this for alpha, right? And so we can take this alpha over to this side and just say this is going to imply that alpha hat is going to be the expected value of log wages minus gamma hat times the expected value of years of schooling, right? So this is our first equation. However, we still have this alpha hat in terms of gamma hat, which we have not solved for yet. How are we going to solve for gamma hat? How are we going to solve for gamma hat?
Take the derivative.
Say that again?
You have money in 0 for SI?
No, but it has to do with SI. The value of gamma hat should do what for SI?
Will that be 0?
So let's look back at this. We're going to choose gamma hat so that we minimize SSR, minus SSR, right? And so what do we need to do to SSR to figure out the relationship with gamma? We have one more derivative to take. So we need to take the derivative of minus SSR with respect to gamma, right? And set this equal to 0. Because we have 2 parameters here. And the way that we're going to set those 2 parameters is we have to take the derivative of the quantity with respect to each of those independently and set that equal to 0 to find the maximum. Just like we did for our utility maximization when we had 2 inputs, right? Is everybody clear on that? Okay. And when we take this derivative, that's going to give us something very similar. So what we're going to end up with is going back up here, we're going to end up with minus 2 over n, the sum from I equals 1 to n. And then, so we've taken down this 2 here, right? And in parentheses, we have yi minus minus alpha hat minus gamma SI raised to the power of 1, right? Everyone sees that? And then we can take the derivative of this internal piece here with respect to gamma hat. What's the derivative of yi minus alpha hat minus gamma hat SI with respect to gamma hat? Negative SI. Exactly. Everyone sees that? Are there any questions so far? And we're going to set that equal to what? 0, right? Now, what we can do is we can multiply both sides of this by a half, like we did previously. And we have a minus sign here and a minus sign here, so those two minus signs are going to cancel. And the first term we're going to have is 1 over n. The sum of yi times si, right? Because we get this si multiplied by this yi. Does that make sense? Then the second term that we're going to get is going to be minus 1 over n. Is there a question? The sum from I equals 1 to n of alpha hat si, right? Yes?
Do we need I equals 1 at the front or no?
Yeah, we can put it here. Sorry, I missed the I equals 1 to n. That's going to be a lot of places. Okay, so far we have, so we have yi times si, then we're going to get alpha times si. Question?
So I think I missed something, but why is the first term negative and the second term, or why isn't the first term negative and the second term positive? Because it's a negative SI. So wouldn't you, why not?
Oh, we have a negative here, and we have a negative here.
Oh,
And those
I
two
missed the
cancel
first
out.
one.
And then this term is just positive, and this
Okay.
term is just negative, and this term is negative. Does that make sense?
Yes.
So then we get a minus 1 over n gamma hat si, and then we're also going to get a minus 1 over n sum from I equals 1 to n gamma hat si squared is equal to 0. Does anyone have questions about this so far? Anyone follows this? Okay. All right. Now, we can rewrite this as this is the average of yi times si. So this is just going to be, can you guys in the back see down here? You see over here? Okay. So this is going to be the expected value of yi si. This term here, we're just going to take out a factor of alpha. And so that's going to give us minus alpha hat times the expected value of si. And this term here is going to give us minus gamma hat times the expected value of si squared. And that's going to equal to 0. Everyone follows this so far? So what we have here now is we want to solve this for gamma, right? I'm going to erase this here. What time is it? 12:03. Okay, good. We have 12 minutes, so that gives us plenty of time to finish this. All right. So let's call this equation 2. So let's rearrange equation 2 to solve for gamma hat. When we rearrange equation 2, what we get is that gamma hat. Okay, no, let's do this. Sorry about that. Let's substitute equation 1 into equation 2. Because we have a set of simultaneous equations, right? Each of these expectations here is a function of the data. We know what the log wages are, and we know what the schooling is, so we can compute this data, right? We can just take the log wages multiplied by the schooling, add it up for everybody, and divide it by 1 for n. We can figure out the average schooling by just looking at the data. We can figure out the expected value of the average schooling squared by looking at the data too. Just take the schooling for each person, square it, add it up over everyone, and divide by n. Everyone understands that? The two unknowns are this alpha hat and this, the gamma hat and the alpha hat. So when we substitute in 1 into 2, so we're going to substitute this value of alpha into this equation here. What we're going to end up with is the expected value of YISI minus alpha, and alpha, remember, is this quantity here. So it's going to be minus the expected value of YI minus gamma, the expected value of SI. So this term here is just alpha. That. And then we're multiplying this by the expected value of SI here. And then we have a minus alpha, a minus gamma, sorry, times the expected value of SI squared. So minus gamma hat times expected value of SI squared, and that's equal to 0. Everybody with me so far? Who's not with me? Okay. So let's simplify this, right? So this says the expected value of yi times SI minus, this is the product of these two things, so minus the expected value of yi times the expected value of SI. Okay? And then here we're going to get plus gamma, because we have minus times a minus, which is a plus gamma times the expected value of SI, and this quantity is squared. So this is just the expected value of SI times itself. That's expected value of SI, which is different from the expected value of SI squared. Okay, and then we get minus gamma hat, the expected value of SI squared is equal to 0. Everyone with me so far to this point here? Yes?
What is this finding here?
This here?
Like this whole equation right here?
We're solving for gamma hat. So what we did was we took the first order conditions and we set that we took the derivative of the sum of the square residuals and set it equal to 0. Once we took the derivative with respect to gamma and alpha, and that gave us two equations and two unknowns. These are the two equations here, equation 1 and equation 2. The unknowns are alpha hat and gamma hat, right? And we're solving this as a system of simultaneous equations. Everyone's on board with me? Okay. All right. Now what's going to happen here is this term here is the same thing as the covariance of yi and si. We showed this in the previous class, okay? And this here, we can rewrite this as minus gamma hat times the expected value of si squared minus the expected value of si times the expected value of si, right? Is equal to 0. And this term here is the covariance of si with itself, which is the same thing as the variance of si. Right? Everyone sees that? This is just by definition. The covariance of two things is just the expected value of the product of those two things minus the expected value of each of those individual things multiplied by itself. So this here is just a definition. Does everybody get that? Any questions about that? Okay. So this implies that the covariance of yi and si minus gamma hat times the variance of si is equal to 0. So from this, we can solve that gamma hat is equal to the covariance of yi si divided by the variance of si. Any questions on this? Sure. But are you following everything? So everyone has me up to here, right? What we did was we just took equation 1 and substituted into equation 2 for alpha hat. Once we substituted in for alpha hat, we have expectation of y minus si. Where we saw alpha hat, we put in the expression for equation 1, right? And this is equal to 0. When we go down to this line here, we multiply everything until we get the expected value of si times expected value of y, which gives us this term here. And then the second term, we get the expected value of si multiplied by itself minus this piece here. here. And what we do next is we collect terms. This term here is the same as the covariance between yi and si by definition. This term here is by definition the variance of si. Right? So that brings us down to this line here. And when we reach this line here, we just have this is all of this here's data. We know what yi is, we know what si is. We know what si is, so we can compute the variance of si, we can compute the covariance of si with yi. The only thing that we don't know is this gamma here. So now we can solve the gamma hat, and we can say that the best gamma hat is going to be the ratio of the covariance of yi and si to the variance of si. So the whole point, remember, was to take the data and to use the data to figure out what's the best predictor for the marginal rate of return for education. Does everybody understand this? If you understand this, raise your hand. If you don't, raise your hand. Okay, question.
I just haven't had time to process.
But you understand all the steps.
Yes, because I kind of just went over it like the different class, but
Okay.
still like.
So, yeah, do you have any specific questions? Do you have any specific questions, Tim?
It's just been difficult for me to critically evaluate each step. I have it, and I think I can go back and understand it, but it's just been difficult to try and evaluate exactly what's going on in each step.
Okay. Would I, Anna, you have a question?
I just don't think I'd be able to realize that it's the covariance and like relate all of it.
Okay, so in the last
I
lecture,
understand.
this is just the definition of covariance. That's all. You understand what this is? We can also
just
write
don't
this.
recognize it.
Instead, let's just write this as the expected value of yi si minus the expected value of yi times the expected value of si divided by whatever the term. That's all we're doing. Does that make sense?
Yeah.
We're just giving it the name covariance because that's what it is. Let me. You had a question.
Yeah, so we did all this math. Could you just like give me a theory question? Like, what would the question be on the homework that would require this math?
You'll see the question. That's it. So I'll hand it over in a second.
Okay.
Let me finish this. Let me just finish this. So the last thing we have to do is figure out what's the alpha hat. And so the predicted alpha is going to be just this expression here, right? So what we're going to get is from equation 1, we're going to get alpha hat, and it's going to be the expected value of yi minus gamma hat, right? And gamma hat we showed was the covariance of yi and si over the variance of si. And that's going to be multiplied by the expected value of si. So this is just literally plugging in this equation 4 here into equation 1. That's literally what this is doing.
So we just found the wage estimator for that.
Exactly. So going back to our empirical, so we had this data where we looked at where we had the years of schooling, and we also had the years of schooling, and we also had the wages. And the question was, what is the rate of return to schooling, right? Essentially, like, what's the best line that we can fit through the data? And so the point of this exercise was to say, if we take as our criterion trying to minimize the prediction error, then what would happen is we can take that, we can look at the data, we can look at the covariance between the outcome, which is the log wages and schooling, and the variance in the amount of years of schooling, and we can use that to predict what's the average rate of return for education in that data set. And so any data set that you get that has this particular structure, you can know that the slope is going to be given by the ratio of the covariance to the variance, right? And similarly, you know that the intercept is going to be given by this expression here too. So this is just telling you how do we fit the data to, how do we fit the model to the data? Okay. Let me, yeah, go ahead and ask questions. I know that we are, I just want to hand out the homework, and if you did update the homeworks, please hand them to Shannon. So this is, yeah, so these are the updated homework, so this will cover present value, and this will also cover, regression analysis. And so I want, next lecture,
Are you gonna
what's
be in
gonna
your
happen
office?
is, we're gonna
Until about one.
be, yeah, next lecture will be in the lab. I'll send out some details about it, and you'll be able to go through some of the stuff on Stata. So I'll send you out a Stata guide to go through to familiarize yourself with this.
There's only just one extra part.
Is everyone finished writing the notes?
Are you gonna copy the homework yet?
Yeah.
Yeah.